So using the 555 simple astable oscillator with a 4051 multiplexer, because our common connection can be either for an input or an output, we can use it in either direction. That means that we could wire this up in one of two ways. If you look back over at my image, remember we want to connect pins 3 and 6 through some different resistors. So we could either connect pin 3 on our 555 to the common on our 4051, or pin 6 to our common pin 3 on 4051. Because it can go either way, because it works in either direction, we can just make that choice. I have it drawn out, so I'm going to be connecting pin 3 on the 555 to pin 3 on the 4051.
She's off.
And so remember what this chip does, right? By putting voltage onto some combination of pins of A, B, and C, we can select which one of these numbered 0 through 7 channels will be electrically connected to our pin 3, our common pin, right? So what we're going to do is we'll have our common pin connected to our 555 pin 3, and then we will have all of these other channels. Sorry, that selected very strangely. There's a weird PDF formatting thing happening. But so all of these 0 through 7 channels will be wired through a different resistor that then are all in parallel connected to pin 6. So I'm going to go back to my drawing. So here, let me see if I can get that focused a little better. One second. That's a little bit better. So here we're going to have pin 3 on our 4051 connected to pin 3 on our 555. And so then all of these that are attached to pin 6, there will be different resistors on those that are all then connected together in parallel to pin 6. And each one of these is going to go through, I'll just write 0 through 7 for all of these channels 0 through 7. Let me, I'll just write channels. Not the pin numbers, because remember we have different, oh, 1 second. Because our channels are numbered on these numbers that are outside of the rectangles, the squares that delineate our pin numbers. A little awkward, but it's easier to write channels 0 through 7 than it is 13, 14, 15, 12, and yeah, 1, 2, 4, 5, 7, all blah, blah, blah. So anyway, we're also going to have our pin 8. So this VSS, that's going to be connected to ground. So if I write a pin 8 on here, I can just bring that down to my ground. Our VDD, or pin 16, is going to be connected to our 5 volts. Our inhibit pin, pin 6, we're going to connect that to ground, so we're not inhibiting, and I'll just short that over to pin 8 in my drawing over here. And VEE we don't need to worry about. And then A, B, and C are going to be connected to our buttons. Remember, we're going to use a pull-down resistor just to make sure that everything stays at ground, unless we want it to be at higher voltage. So these we're going to, each one of those are going to be connected through a 10K resistor to ground. And then these will have our switches to 5 volts. And that's the same 5 volts as we have up top. So I'll go back to, so you can see my drawing big. 1 second. So this is a little bit messy because I just did it together on paper with pencil. But so we have our 5 volts and going into parallel to our 3 switches. Our 3 switches then are going to, our buttons in the case of what we did, are going to our A, B, and C channels, but they're also being split into a parallel here where we're going through a 10K resistor to ground. So that unless we actively press one of these buttons, all of these A, B, and C channels are natively connected to ground. And then other than that, we have this setup. I mean, it's pretty standard. We have our power and ground to the proper pins, and then our signal here. So now, depending on which one of these, buttons I depress in together or alone, whatever the combination of buttons I press, it's going to route my signal that would be normally going through a resistor through the multiplexer, through one of channels 0 through 7, which will route us through one of these resistors to pin 6, which will then influence how quickly our capacitor can reach charge, which then will trigger the timer to dump that voltage and then restart the process of cycling. So we get that oscillation, that repeating oscillation. So yeah, I'll make a better version of this. I can't do it in Tinkercad circuits because they don't have this chip, sadly. But I'll see about another format for that, or I'll at very least make this in pen and try to color code it so it'll be a bit nicer to look at. But I just want to show briefly what that's about. So, oh, and you might notice that I have a different speaker than you do. This speaker is louder than the one that you have. So that's why I'm using it here for the demonstration purposes. So this might be unpleasant. We'll see how well it comes through the speakers. So I'm gonna move my mic over to it. So I just randomly pulled I just randomly pulled different resistors out of my kit. But what I had asked y'all to look into was if you could find resistors that would make this thing sound good. So yeah, if you were able to record the values of those resistors that were harmonious in sequence as a scale or something, then that would be where you would want to replace all of these random resistors that I have chosen with.